Well, with x going to infinity in this problem, we would have infinity squared plus 2, which is infinity, the square root of infinity, which is infinity. And the same thing would happen on the denominator for the denominator. So we'd have infinity divided by infinity, which is an indeterminate form, which means that this limit could equal 1/2, it could equal 10,000, it could not exist, it could go to infinity, really don't know. So the idea is, with L'Hopital's rule, this top function is going to infinity, and the bottom function is going to infinity. But if one of them, let's say, is going twice as fast as the other one, you could look at their rates and divide, and you would get either 1/2 or 2/1, but you would get a limit. So let's try it. So first of all, try to indicate, either write out the word or some abbreviation saying, I'm using L'Hopital's rule now. That's the limit as x goes to infinity. And then we need to take the derivative of each function. So the derivative of the square root function is 1/2 times the square root function. And then derivative of the inside according to the chain rule, which will be a 2x. And do the same thing for the denominator, so it begins with 1/2 times the square root function. And the derivative of the inside function will be 4x. And then, to divide two fractions, invert and multiply. So this one, multiply by 2 over the square root of 2x squared plus 1 divided by 4x. And do that for the top and the bottom. 2 square root of 2x squared plus 1 divided by 4x. So that these can cancel. These can cancel. Also over here, well, these 2's will cancel. These x's will cancel, and 2 will divide into 4 2 times. That was a lot of canceling. So then limit as x approaches infinity. So now I don't write anything over here, so I'm just doing algebra. So the denominator is completely gone. Over here, the numerator has this square root of 2x squared plus 1. The denominator has a 2 in it, and then that radical. Okay, so basically what we did is a whole bunch of work to get an extra 2 out of it. So perhaps the answer is supposed to be 1/2. The only problem is this right here is pretty much the same thing as this over here. So if we did L'Hopital's rule on this, we would end up doing all of this work again. And then these two guys would just switch places. And then we would have to do L'Hopital's rule again, and then we would end up with this back again. And so we just keep going in circles, which then means we need to try something else. So we could use some algebra, like for example, so the 1/2, just move it off to the side for a moment, the 1/2. And then since both of these are in radicals, you can make it one big radical of a fraction, 2x squared plus 1 divided by x squared plus 2. And then experience is telling me that if x is going to infinity, plus 1 and plus 2 doesn't matter. You basically just have that. And if you basically just have that, then the x squares cancel, and you've got the square root of 2. So the answer is going to be the square root of 2 over 2. Well, that's my intuition. I need to actually show some work and prove it. So when you've got a fraction like this with different terms and you're not able to factor or anything like that, another idea is you take the leading term, here it's x squared, so you look at all of them, all 4 of them, and out of those 4 terms, the most powerful thing is x squared. So divide all of the terms by x squared. So the numerator and denominator, have to do it for both of them. So limit as x goes to infinity. The 1/2 is out here minding its own business while we do some fancy algebra inside the radical. So this would cancel the x squared, leaving only a 2. And then distribute, so it's going to be 1 over x squared. And then distribute, it's going to be a 1. And then 2 over x squared. And now let x go to infinity. So 1 divided by infinity, so if you take one particle and divide it into an infinite number of pieces, the size of each piece, 0. Likewise here. So 1 divided by infinity squared is 0. And so sure enough, what's left is just numbers. The square root of 2 on top and a 2 on the bottom. Square root of 2 over 2. And then I want to take a look at the graph. So here's the original problem. Square root of x squared plus 2 over square root 2x squared plus 1. And then have the window go out fairly far. We'll try 25. And see if the graph is leveling off somewhere. Yep, that looks pretty leveled off. And the next thing is trace and see where it leveled off. It seems to have leveled off at 0.709 or 708. Okay, so just remember 0.708. Then the square root of 2 divided by 2, is that anything close to 0.708? 0.707. So that is the actual limit.